Their application of the law of cosines is a navigation problem. So we're going to talk about heading and bearing. So here's some new notation that you may not have seen before. When we talk about direction and we're giving angles, whenever we say north 30 degrees east, then we're actually measuring the 30 degrees from north. We're saying north 60 degrees west, and we're measuring between north and west 60 degrees from north. If we're saying south 70 degrees west, then it's going to be 70 degrees from south towards the west, right? So this is sort of like a new way to think about angles, but we still have to use, so we can use this in order to find the angles of a triangle. So let's look at this example number 4. A pilot sets out from an airport and heads in the direction north 20 degrees east, flying at 200 miles per hour. After 1 hour, he makes a course correction and heads in the direction north 40 degrees east. Half an hour after that, engine troubles force him to make an emergency landing. A. Find the distance between the airport and his final landing point. B. Find the bearing from the airport to his final landing point. So if you look at this drawing, this image here, this gives you an idea of how the pilot traveled. We started from A, went to B, and then had to make an emergency landing at C, right? So we're given some information, flew for 1 hour, 200 miles. Let's make some additional notation here. So this distance between B and C is going to be A. This distance between A and B is going to be C. So C equals 200 miles. And then between A and C is going to be little b. So if we're asking about the distance between the airport and its final landing point, we're actually thinking about the distance between A and C, which is little b. So in order to find that, we have to figure out what the angle of B is. And that may seem kind of difficult given that we have this angle here is 40 degrees. We know this angle here is 20. And given what we know about alternate interior angles, we also know that this angle here is 20 degrees. So if we look at, let's change the color of this pen a little bit. If we look at this angle here, right, this is 180 degrees. Minus 40 plus 20. So in order to figure out what B is, we can zoom back out, B equals 180 minus 40 plus 20. And so you get 180 minus 40, which is 140, plus 20 equals 160. So B is 160 degrees. So so this whole angle here, and I can erase all of this stuff that I just made. We can. This angle here is 160 degrees. And so now we should have enough information to solve for B. So we're going to use the law of cosines. B squared equals A squared plus C squared minus 2AC cosine B. B squared equals, and then A squared, right? We said A is 100 miles. C is 200 miles. Minus 2 times 100 times 200 cosine of 160 degrees. And then we could plug this into our calculator. We get 100 squared plus 200 squared minus, parentheses, 2 times 100 times 200 times cosine of 160. And you get about 87,587.705 ish. Take the square root of both sides. And then b is approximately equal to 295.95. And I think we're talking about miles. So b equals 295.95 miles. And you can round that up to 296 because it's close enough, I think. So this is the answer for part A. Part B asks, find the bearing from the airport to his final landing point. So what we're looking for is this angle here, the bearing from the airport to his final landing point, so the angle A. So we could use law of sines here. Sine A over 100 equals sine 160, we can use B this time, over 295.95. And then sine A equals 100, multiply 100 by both sides, sine 160 over 295.95. And then A equals the inverse sine of that. And let's plug that into a calculator. We got 100 sine 160 divided by 295.95. And you get something like 0.11. So inverse sine of 0.115567. I'm going to keep as many decimal places as I can. And you get A is about the inverse sine of that. And you get about 6.636 degrees. And then if we wanted to find the other angle, we could just subtract those two angles from 180. And this makes sense. So if this is the angle, right? So this is the amount of angle here. And then this is due north, right? So if we wanted to put it in our new directional notation, if this is north, south, east, and west, and this is 6.63 degrees, then in order to talk about the bearing from north to east, we could rewrite this as like a 6.636 plus 20, right? We could write it as north 26.636 degrees east. So this would be the answer for B using our new notation.